Okay, if and only if implies necessary and sufficient condition. Okay. So if A implies B, okay, you say that this is a sufficient condition. Okay, like for instance, you want to get a grade of A in this course.
One that implies B.
You have to turn in all your homework. You have to get over 90% correct in your homework. You have to take all the 3 exams plus the final exams and get a score of 90% on all the 3 tests. Okay. Let's assume that that is the.
And you just score 100 on your lab.
Okay. You have to get high scores in all the things that you have done, then you get an A. Okay. Okay, so this could be those conditions that you have listed in A. That would imply B. A sufficient condition is something not. A necessary condition is something that's weaker than a sufficient condition. Okay? It almost is like B implies A. And A is a smaller subset. Okay, for instance, if you get an A in the course, that means that you have turned in your homework. Not necessarily getting grade of 80 and higher in your homework. It just means that turning in your homework. So A can be turning in your homework. Okay. Getting an A in the course implies that you turn in all your homework. Okay. So we say that A is a necessary condition. So if you say that H is absolutely integrable, it's a necessary and sufficient condition for B-ball, that means that it implies that let's call this condition AI, absolutely integrable. Okay, AI plus bounded input implies bounded output. Okay, so we have proved that if you have AI being absolutely integrable, I mean if you have HT being absolutely integrable, you have bounded input, you get bounded output. Okay, but you also have to prove the other condition that you have bounded input plus bounded output, you will get AI. Okay, we have not proved the second condition yet. That is, if the input is bounded, if the output is bounded, that impulse response must be absolutely integrable. Okay, let's see if you can prove that in the last little bit over here. So I can actually concord a case, which is done in the example of the book here. Okay, I can have f of t being just a sine function of h of t. Okay, f of t is something that flips the sign according to the impulse response of the system. Okay, I don't know. Say the impulse response h of t can look something like this. Okay? And then f of t is equal to the sine of this. Then if I were to write the output y of t, it will be convolving h of t with the sine of this h of minus t minus tau. Okay, d tau. Let me put this as tau. Okay. So the output will be given by that, but I'm interested in the case where t is equal to 0. So I let t is equal to 0 and rewrite this as being equal to that. And get the h of tau over here. Okay? And then if I look at this, this second term always follows the sine of h of tau. So this is just equal to magnitude of h of tau, d tau. Okay? And that is just equal to that. And what I want to say is that if the input is bounded, the output is bounded. If this is bounded, this is bounded. Okay, it must mean that this must be bounded. This must be bounded. Okay, because I assume that the input is bounded. This is bounded input. The input is given by this, and if this is bounded, then this is bounded, then I would have this as being bounded. Okay, so this is the example where if you have bounded input and bounded output, then AI must be true, absolutely integrable. Let's assume that this is not true. If this is not true, okay, then the output will not be bounded. Say if this is not bounded, this will not be bounded. Okay, so this implies that bounded output implies AI. This is AI, absolutely integrable. Okay, so this thing is improved two ways in the textbook, and it's true and only true if the impulse response is absolutely integrable. Okay. And then there are a number of examples in the textbook on this kind of thing. Okay, this is also called Beeble stable. Okay, another term for this is Beeble stable. The system is Beeble stable if its input is bounded and then its output is bounded. Okay. I don't think I have enough time to go through another example, so I'll let you go here. There are lots of examples in these two sections. I guess you can read them by yourself. 10.1 and 10.2.